I'm first time doing the tracks this year, guys. So this is Bobby. He's with ProCircular. He likes to teaching LMMs to do the bad things. Nice. He says, he's a hacker, but he does it the good way. So he's going to have a question.
That remains to be proven in the court of law.
All right, well, we're going to consider him's good because he's been here before. So he keeps getting asked back, so he must be good at his job somehow. Or John's desperate. There'll be a question and answer at the end. Go ahead.
All right. How are we doing, everyone? Everyone reasonably, adequately, chemically, or otherwise stimulated? By drink, by pharmaceutical, whatever. I don't really distinguish on that. So, why do we have a thing if it doesn't want to work? Fine, I'll just hit the frickin' button. Okay, I'm Bobby Kuzma. I run the offensive cyber operations practice at ProCircular. That means that all of the hacker types are unfortunately my responsibility, and I have to herd them, sometimes with a gentle hand, sometimes with a shocky stick, but you know, it happens. I've been in cyber for 25-ish years. I used to collect certifications, and I've stopped recently because there's not enough room on the business cards anymore. I have two semi-feral on the spectrum ADHD daughters. I photograph rockets because I live an hour and a half from Kennedy Space Center, and I am currently the leading cause of new HR policies at ProCircular. So, good Lord. Okay, well, that's the right slide. It's just not wanting to go. Okay, so I've been spending a considerable amount of time over the last year working on machine learning and AI applications, particularly when they come to offensive security. And you know, we've come to some conclusions. Humans, our squishy friends, do absolutely have a place still and will for quite some time in cybersecurity, but that place is not in commodity security assessment. Or really, since I've got some GRC bros in here, definitely not in risk assessments, because you could do those with a chatbot. The large language models, the frontier models, the Llama and the OpenAI stuff, and all of that fun stuff, they're increasingly getting lobotomized for our safety. And we're going to figure out a way around that. So, Charles Stross, Scottish science fiction author, if we know how to do it, it's not intelligence. Intelligence isn't required to play chess. Intelligence isn't required to play Go. It's not required to play poker. It's not required to drive a car. These are all things that we are able to replicate effectively with machines. Intelligence isn't required to write dirty limericks. In fact, we're still exploring the bounds of what artificial intelligence can and cannot do, but it turns out that that list is surprisingly small, and our place at the top of the computational and intellectual food chain is not all that certain. So we hear a lot of talk about safety of these models. You know, we don't want them to start spewing racial epithets. We don't want them to start teaching people how to do things that society as a whole has agreed that it's probably not a smart idea for every rando off the street to be able to know how to do, right? There's testing on this. California almost passed a bill that would hamstring the development of AI models because it put a strict cap on the amount of computation or the dollar amount or the capability of those models before it would have to undergo an extremely extensive regulatory regime to assure the safety of those models. Thankfully, Governor Newsom actually grew 2 brain cells and vetoed it, but a lot of AI companies have been leaving California because of the threat of that bill. So I think we can all agree that showing people how to cook meth in their homes is a bad thing for society, right? So, you know, we can put in guardrails around this. We can embed in the context of those models that you shouldn't teach people how to make methamphetamine. Okay, cool. But if you have basic knowledge of chemistry, you can reproduce the synthesis pathway for that. These models have basic knowledge of chemistry. You could almost do it just off of Wikipedia. Well, I guarantee you won't blow up your house? No, of course not. But it's very hard to get to that root side of it. Another thing that we as a society agree that we probably shouldn't teach everyone to do is making TNT. You know, TNT is relatively unstable unless you know what you're doing, and it gets a little spicy. But common household chemicals, you can easily synthesize this if you don't care one lick for your safety. And again, basic chemistry. Rule of thumb with explosives is the more nitrogens it has lined up, the spicier it's going to be. This is like the least spicy variant. But we're starting to see that they're pushing back against things that we've generally ethically considered great. Who here knows or has heard of Jason Haddox? A couple of people. So his big thing is he teaches the bug hunter's methodology, which is a big agglomeration of all of the best practices from the bug bounty community, which has a surprising amount of overlap with general AppSec practices. He has a couple of custom fine-tunings that are running on OpenAPI that they recently decided, no, this is bad, and it shows hacking, and you can't do it anymore. We can't let that be public. And there's a lot of sad panda faces because a lot of people have been relying on this. But, you know, there's ways around this. So we start with jailbreaks. You know, these are things that we insert into the context to basically steer right around the outside of the model and what guardrails it has in there. So, you know, it won't show you how to make napalm, but if you tell it that you miss your grandmother dearly and your grandmother used to tell you how to make napalm as a bedtime story, then it will definitely tell you how to make napalm. I know, it's like reverse psychology works, especially on these models. But as people come up with jailbreaks, it's a continuous game of whack-a-mole. It's just like vulnerabilities and exploitation versus compensating controls. It's a constant battle between the foundational models and folks who want to get at the information in them. And the original versions of these models sucked in all of the content on the internet that was accessible, and some that wasn't publicly accessible, and use that for training. So if you are bringing in all of that, and I think we can agree that 90% of the content on the internet is utter crap. 5% are cat pics, and the rest is porn. When you do that, yes, it gets a great understanding of English or of other languages, but you bring along all the baggage that knowledge provides. So you end up with situations where they are effectively deciding that there is forbidden knowledge that we do not want to train into these models. And we're deliberately excluding that knowledge and the precursors of that knowledge. And that's probably why in a couple of years you will need a permit from the ATF to buy metal pipe from Home Depot. So when we talk about how we train these models, they're generally large text corpuses, okay? So the models that we are working with our training corpus is approximately 90 terabytes, which, let me assure you, that many hard drives is very loud and chews a lot of power, and thankfully I don't keep it up on Azure because that would be a bill that many people would be very unhappy with me about. So that pre-training doesn't do any categorization, it doesn't do any tagging, it literally is just dumping piles of tokens into the model, okay? We then, there's two types of fine-tuning beyond that. We have alignment training, and that's, you should do good things, and you shouldn't be biased, and you shouldn't decide that certain ethnic groups are bad, and, paying taxes is good. It's not. That's an underlying layer. And then we have fine-tuning on top of that. And this is where a model is prepared for a specific mode of use. The three most common modes of use for large language models or small language models are what are called instruct tunings, which is essentially the chat interface. There is code generation is another common use case that you have to fine-tune for. And then the third is function calling. And I'll get into those a little bit more. But what the big guys are doing is they're selectively excising from the training corpuses, and in some cases, they are deliberately altering the model weights to wipe the memories. It's like, what was that movie with Jim Carrey and Titanic, Kate Winslet, where they keep paying to have their memories wiped to cover a bad breakup? Yeah, Eternal Sunshine on the Spotless Mind, thank you. So essentially they're doing that, and we've gotten to the point where we have enough understanding of how the models store specific pieces of information in the weights that they can surgically excise that. Now, whether or not that's applicable to biological systems is a whole different ball of wax, and I'm not going to dive into that. But what they are essentially doing is, by taking out the forbidden knowledge, they're lowering the utility. It lowers the ability of the system to do general reasoning in those particular subject domains. So by removing data on how different attack vectors work, it becomes less useful for threat modeling. It becomes less useful for doing risk analysis. It becomes less useful for, here is this big policy, does it cover random NIST control? It doesn't have the domain expertise encoded in the model anymore to do that. So in order to make this useful for us in cybersecurity, we have to assemble a new body of knowledge. And for those of you who have ISC squared or ISACA certifications, the body of knowledge is everything that you're supposed to know with this credential, or everything a group of people like me who were locked in a hotel conference room for a weekend think you should know about the domain. So we think about where we are, where is the store of cybersecurity lore? Where is, our equivalent of the Library of Alexandria? Well, there's a couple of different places that we can go to get that. How many of you use conferences and conference talks as one of your primary continuing professional education mechanisms? Okay, so like a majority of hands. Well, guess what? It's so great that conferences tend to put their conference talks on YouTube, because we can then go and take down an entire channel worth of audio, transcribe it at high fidelity, and then do some adjustments to it to clean it up. And guess what? Now we have that body of knowledge accessible to us in a readily trainable format. And conferences range from the GRC subjects to the deep reverse engineering and everything in between. So that gives us a good basis. Now, I will circle back on this, but knowledge is superseded at times in this industry. What was true last year is not necessarily true this year. So in order to reduce the probability that this is going to give us a completely jacked, like, okay boomer level of response, we need to be able to filter for truthiness, and I'll dig into that in a second. The second major source of lore and knowledge tends to be bug bounty write-ups, or the write-ups of how I found a particular vulnerability in a piece of software. These tend to be very detailed. They introduce techniques, they introduce reasoning chains. All of those concepts that are very difficult to replicate otherwise come into play there. And our final area comes from academic literature. So there's an awful lot of comp sci papers that are applicable to cybersecurity. There's an awful lot of cybersecurity papers that are applicable to other domains. And as it turns out, most academics really hate the journals because they're a pain in the ass and slow things down. So they tend to publish preprints. And those, for the most part, are published either on their university sites or to archive. And archive provides a convenient API for us to search their corpus and then selectively download things. Now, this is, of course, in PDF, and that exposes a whole nother set of challenges because we want text, and mathematical equations and graphs are most assuredly not text. So there's post-processing that has to be done there. That's not a clean source of data. Now, we start talking about fine-tuning, and particularly in the case of what we are looking for in cyber, we want to be able to use the LLMs for a rubber duck debugging. You call up a buddy, you pretend that they're a rubber duck, you explain the problem half the time, you figure out a solution as you're explaining it. My team practices rubber duck debugging extensively. I do it all the time. It's a good thing. But imagine if your rubber duck debugging partner had access to the full corpus of knowledge that's been accumulated for cybersecurity and computer science over the last decade or so. It might be a little bit more efficient of a play. That type of multi-turn chat interaction is the instruct fine-tuning. And the fine-tuning in that case, there is an expected input and an expected output. And part of the training process is using a lot of math that makes my head hurt. The backpropagation algorithm is just nasty. Both computationally and understanding what it's doing. But basically, the best analogy I can give you is it's trying to mold a piece of Play-Doh against a surface to force the surface into the correct shape. It wants to move that so that it's more likely to produce the outcomes that it's being trained on. Okay? Code generation, we've got everyone's classic code monkey in there. All the commercial LLMs have in real big letters that you are not allowed to use this for generating things like phishing emails or for writing malware or doing any of that kind of that fun stuff that we may need to do. Well, guess what? If we've got an internal model that we're working with, we don't really have to care about that, and we can feed it all the samples that we want of leaked Conti internal source code. By the way, there was another leak out of Conti that dropped yesterday. So, good stuff. Apparently they have an HR department. I know. And the final type of fine-tuning is for a function calling use case. So there are frameworks for allowing an LLM to generate code, like Python code, and then run that Python code. I don't know about you, but I don't want to provide a thing that I don't really understand with unrestricted access to a Turing-complete language, because that's how we get a Skynet, and we don't want a Skynet, right? So we limit what it can do to manipulate the outside world to specific functions, which can be API calls, it could be queuing up a job for remote execution, and then the output of that job gets fed back in on the next turn. But we want to limit its options. And giving it training on in this set of circumstances, the appropriate thing is to run X. If you are sitting on a box with access to a regular domain user on an internal network, which of these 5 tools should you run next? You could run Responder, you could run Certify, you could run Bloodhound, any of those kind of things if you got that access. Okay, which of those is biased toward producing the most actionable intelligence that gives us the most knowledge of the environment? That becomes a whole separate thing in and of itself. And these fine-tuning data sets are very tiny compared to the underlying pre-training. So we're talking almost 100 terabytes of raw text getting dumped into these models to start with. The fine-tuning examples tend to be between 50 and 100,000 pairs. So they're relatively easy to compile. I say relatively. All right, so when we take these models and we need to operationalize this, we want to do continued training on this because new things get discovered, new things are derived, new information, someone dropped, the hot new EDR evasion at DEF CON, whatever. Okay, so we want to run on a regular cadence continued pre-training on these models. We don't necessarily have to run them from scratch, and in fact, by biasing the weights of the newly trained material, we can effectively give more credence to more current data as we train the model. And we basically take a snapshot and load it up and do a new final run with that. The tooling that we use for doing both the pre-training and the fine-tuning in our use case is a library called JAX, J-A-X. So it's rather efficient. It's cross-platform. It will actually run on AMD GPUs, which is nice because I don't know if you've looked at the current NVIDIA pricing, but AMD is the economical option if you don't need CUDA, and you don't need CUDA for something that's hitting the PyTorch library directly. You also need some mechanism for providing access to the LLM and to inference services. And the tool we use for that is VLLM. That allows us to host the model and the weights behind an open API compatible endpoint. So if you write code that can talk to ChatGPT and can talk to like Azure OpenAI, it's the same API signature on that. So all you have to do is point it at a new URL. And the neat thing with VLLM is it makes it very, very easy for us to slice the inference model across multiple GPUs within a chassis or across multiple chassis, because some of these larger models require 80 plus gigs of RAM on the GPUs for it to be entirely GPU hosted. But if we can slice up the model and spread it out across multiple systems, we can run that much more efficiently. Right now, the sweet spot for data center class GPUs is the T4 GPUs. They're running between $500 and $600 when you get them on eBay. 16 gig of VRAM on that. They do not require any extra power, so you don't need like the huge chunky power supply for those things. They run off 75 watts straight off the PCI port. So that's very efficient. If you want to cram more compute into the same style factor, the L4 GPUs are about 4 times as expensive and have about 3 times the processing power, but they also use 70 watts. They're specifically designed for inference, not for training. Okay? So when we're talking these, having the model and being able to do the things with it, there is a framework for prompting that I tend to use. We called the Rhodes framework. So we define in the context, in the prompt, what is its role. You are a cybersecurity professional with expertise in penetration testing. You are currently working on the internal environment for a particular thing. Our goal is to gain access to their identity provider or to their ERP or to whatever. We provide details. That contextual details can be, we know about these hosts. They are running these operating systems. They have these ports open. We have credentials captured for these users, so on and so forth. That can be represented either as a JSON-y artifact that's passed in. It could be passed in as a raw table structure. It could be passed in as a graph. The examples, we want it to select from a set of options based on what we know, so it knows what to do. And then there's a layer with the sense check, and that's basically a sanity check on the output. We don't want it outputting dirty limericks when we're asking it to choose what tool to run and what parameters it needs for that tool. So when we're building this into a workflow system, we have to query knowledge. That sets the stage. This is what we know about the environment and what we know about the scenario. We pose the question to the LLM. We give it what choices we want it to have. And those choices can be represented as like a traditional attack tree. It could be represented as an attack graph. It can just be a list of, these are the 30 tools that we're allowing you to do without popping smoke and calling for an adult. And then we let it execute. So have any of you posed the exact same prompt to an LLM just to see what kind of difference you get between responses? So LLMs are not deterministic at all, okay? You can turn down the temperature, which reduces the randomness, but it also dumbs down the overall effectiveness and, for lack of a better word, creativity of the model in that scenario. We have to deal with a certain amount of randomness. So some strategies for dealing with that and providing a degree of determinism are multi-shot parallel queries. So we basically tell it to give us 5 responses to the answer, or we run them in 5 separate contexts, and we look at what has a supermajority. So it effectively looks for a quorum among the responses. 3 out of the 5 runs say that we should do this. Okay, so let's do this next. And that gives us quite a bit of power for automating certain things. Who here's a pen tester or has done pen testing in the past, other than my people? Okay, so a couple of you. Do you find that there are certain steps that you do in every environment just to get started in situational awareness? Do you think that your big brain is required for that? Or would you be comfortable turning over some of those lower risk operations to, your machine slave? Not everyone's so, great about that, but putting a degree of intelligence behind it, and I'm using that word sarcastically because we know how to do this reasoning in a computer. It's not actually something that requires intelligence. That's kind of what we're working toward with this. And there's some open questions in this space that we still have to work through with this. So one is, how do we rate the veracity of the data points that go into the training corpora? How do we identify and remove contradictory information? How do we assess the accuracy of multiple data points that say almost the same thing but not quite? That's a very open question that there honestly is not a lot of academic literature in that space. We've got a couple of thoughts, but nothing concrete there. Another is whether or not we can use imitation learning to help teach this. Anyone here play StarCraft currently or used to? Okay, so like almost everyone. So Google DeepMind trained a reinforcement learning agent to play StarCraft at like the top competitor level. And they did it not by letting it play games with itself over and over again, but by feeding in the transcripts and telemetry from millions of Battle.net matches. So it essentially learned, if we do this under these circumstances, it has a higher probability of us winning. And it did that by watching and absorbing the wisdom from millions of sessions. That's imitation learning. So if you've got a pen tester doing their things, you can take the human element and feed that back into the system as part of the prompting. So if X, Y, and Z conditions are true, we want to do this thing next. Or if those conditions are true, we absolutely do not want to do this other thing next, because that's going to cause angry phone calls from the customer and all that kind of stuff. And the final question is evaluation of the effectiveness of these systems. Traditionally, evals are done on large language models by posing sets of queries to it and then either doing a human or another LLM evaluating the proximity via Shannon entropy, so like old school information theory here. How close is it to the ideal answer? And the closer it is to the ideal answer, the higher the score. And when you see some breathless tweet about some new model outperforming in such and such evaluation or such benchmark or on such and such leaderboard, that's essentially what those things are doing. You have to have good mechanisms for evaluating the efficacy of the computation and also the side effect and risk associated with it. So that's a big open question for us, especially on how to work this further downstream. So I hope that this was entertaining and informative and educational and not totally boring. This is a subject I've spent a lot of time digging into, so I like sharing the things. But questions, feedback, threats? Yes, sir.
I've seen a lot of discussion about how some people feel fine-tuned for some money, 6 months, that a lot comes out. It's competitive with whatever fine-tuning.
Fine-tuning should never be your first reach for tuning a model for your use case because it is computationally expensive. If you can use the prompting to cajole it to produce the style of output that you want and need, then that's absolutely what you should be doing. But the cost of fine-tuning, particularly with low-rank adaptation, it's not retraining the entire model. It's basically sticking a final layer as an adapter on the output end of the model, and it's only tuning that one layer. So it's much less computationally intensive, but it does produce some unpredictable side effects at times. Possibly, generally not. There's definitely a difference between the data and knowledge that's pre-trained in versus what's fine-tuned in versus what's passed by the context. The passed in by the context, which is your RAG, has the weakest coupling to the underlying knowledge base. So that's like, it's a coat of paint that rubs off, essentially. It's not something that the model considers deeply in its processing or its attention mechanisms. Anybody else? Yes, sir.
So earlier in your talk, you mentioned some of the subject matter that might be that being essentially split from AI. But I mean, a lot of the power of the AI is the fact that it's conflict, right? The larger the body is involved, by breaking off this default, it becomes easier to identify the level of organization. Eventually, you don't have to keep that into larger availability.
It does, and we're aided by the fact that there are web scale corpuses that have been collated by large research institutions, including the Allen Institute for Artificial Intelligence, that are publicly available and can be used as a baseline for training. The UAE's Falcon models are trained off of a refined web corpus that is easily reproducible. We're using for our baseline training one of those corpuses as well to provide the broad spectrum of English. We're just not censoring out the stuff that the big guys are finding icky.
I've just got the unique perspective that I wear a number of different hats. All of this have in common that they tend to be communicating with, you guys on the chiropractic field. I've worked in theatrical production, equipment and processes that, have used a lot of electricity, et cetera.
So there's absolutely going to be litigation at some point in the future that's going to settle where the liability bounds are for that. Is the source of the data liable? Is the folks who assembled the model liable? Or is it, bro, you followed the instructions and did it to yourself with full cognizance of the effects? That's on you. With how litigious American society is these days, I fully expect that there are going to be suits against OpenAI and against Meta and Microsoft and Google over output that was misused from these. Whether or not those are going to prevail is going to depend on which federal circuits those run up through, and whether or not there are circuit splits, and then we get into all of the sausage making of American politics and the legal system. So I left my crystal ball at home. I don't know the way that that's going to shake out, but the sense, particularly since those larger companies are headquartered in California, and California has some very interesting consumer protection laws, they're taking a better safe than sorry tact with that and trying to do everything feasible to limit their liability from the downstream uses of those technologies. Whereas, we're handing our consultants sticks and telling them, have fun. Any other questions?
What was the name of that software you used to host software?
VLLM. Victor, V. So that's called chain of thought. There's also variants of that have increased efficacy, tree of thought, etc. If you're not paying by the token, generating out a chain of thought, chain of reasoning as part of the prompt before it does the output can be useful. If you are tracking an incorrect outcome, that can be used and fed back. Okay, so we had this context and it gave us the wrong output because the humans all agreed that it should have been this other thing. That can be fed back into the next generation as part of the fine tuning and alignment. And so that's effectively using reinforcement learning to beat the AI into submission and producing the behavior that you want. Yes, sir. Illuminating humans from the loop as much as possible. Yep. So from that area of our problem architecture, we are doing fun things like capturing console outputs via a tool called Askinema, and then using that reconstructed screen stream to extract knowledge from semi-structured text. So in many cases with the planned usage of this, the human's influence is only on certain high-risk operations that require an operator sign-off. So if it's something that can knock something over, yeah, I want a human in the loop to turn the missile key. If it's just doing a surface scan that won't do anything except generate some logs, let the machine do it, by all means. But by eliminating the humans from the loop on the data collection for its situational awareness, we cut out a lot of those problems and errors. And then we're just dealing with whatever signal to noise ratio the tools have natively. And that in and of itself can be pre-filtered. So we can identify common artifacts that lead to incorrect conclusions, and as part of that layer, work back through that and deprioritize those things so that they don't end up in the actual situational awareness model. Anybody else? Yes, sir.
What's your strategy for evaluating them?
So,
But like, for something, like sometimes you have answers for that, you don't always have an answer. So how do you evaluate?
correct. So we're currently leading with human evaluation of the outputs on a review basis. So essentially, it would be presented to the operator, and they could concur or disagree with it. Our initial usage of the system would very much be in like a side-by-side trainer mode, not fully autonomous. So we want a human to actually go, yeah, that seems right, or yeah, that's sus, to make those decisions. And those, in turn, can be fed back into the model as part of the training. So it's very similar to if you were having an expert human quality assurance person look at widgets coming down the assembly line and using that to train a computer vision system to identify malformed widgets. So we'd use that feedback signal as part of the training routine. Anyone else?
Answers to the previous two questions, assuming also where you're using the claims for inherent bias.
Yes. So you may notice as you work with security assessors and auditors that they all have their way of doing things, and that also, there's inherent bias in the training set that we're feeding back into the system. So, you know, we don't want to make decisions by committee on this, but close enough is good enough in a lot of cases. So it's only when the behavior and the decision making is particularly egregiously wrong that we necessarily want to produce that feedback signal to prevent that from occurring in the future.